Again, Department of Mathematics, SNS College of Technology, Coimbatore. Okay. In the last class, we just solved till eigenvalues. Okay. So now we are at the topic diagonalization of any matrix. So we are going to continue the same problem. Okay. Already we got the eigenvalues, right? So the eigenvalues are the eigenvalues are 1, 2, and 4. These are the eigenvalues of this matrix. Okay. So in today's class, we are going to solve. We are going to find the eigenvector. Okay. For eigenvector, we will have the formula. So using that formula, we need to find the eigenvector one by one. Okay. So eigenvector formula is the formula is what? A minus lambda I into x equal to 0. Okay. This is the formula. So for this case, what is the thing we have to do here? Yes, we just add minus lambda in the diagonal, then we are going to get this term. Okay, so 1 minus lambda, then 0, 0. And 3 minus lambda minus 1. And the last thing is 0 minus 1, 3 minus lambda. Okay, this way on to write a minus lambda. Now tell me what is x? Yes, which is nothing but x1, x2, x3. That should be equal to 0, 0, 0. Okay. Yes. Now here we are going to replace this lambda value one by one. Okay. The first value of lambda is what? 1. Okay. So the first case is when lambda equal to 1. Okay. Put lambda as 1. Now tell me what is the value? Yes. 1 minus 1 is 0, 0, 0. And the second row is 0. 3 minus 1 is 2 and minus 1. And the third thing is 0 minus 1. Again 3 minus lambda value is 1. Okay, that means the value is 2 and which is into x1, x2, x3. That should be equal to 0, 0, 0. Okay, and you will have a procedure here. Okay, to check, actually we need two rows. Okay, suppose we are going to choose first and second, but it is not possible because the first row is all the elements which contains 0, so it is not possible to choose the first row. Okay, go for the next choice, which is 2 and 3. It is possible because that is different rows. Suppose if all the three rows are equal, we know the procedure, right? If it is not equal, we will have separate procedure, right? We can see 2 and 3, whether is it same or different one. Yes, it is not different. Sorry, it is different one. Okay, if it is different, we are going to use cross multiplication method. Okay, that means we are going to start with here. Okay, so the elements are 2 minus 1. You can take the next one as minus 1, 2. And 0, 0, and first and last should be same. So 2 minus 1. Again, you can put the values x1, x2, x3. This way I want to find the cross multiplication method. Okay. Now x1 is what? Yes, just find the determinant of these two elements. Okay. So 2 into 2 is 4. Then minus 1 into minus 1 is plus 1 equal to x2 by. Again, we are going to find the determinant of the next two. Okay. So minus 1 into 0 is 0. Minus 2 into 0 is 0. And x3 by, you can take the remand x2, so which is also 0. Okay. Now tell me the value x1 by 4 minus 1 is what? 3 and x2 by 0 and x3 by 0. If anything is common, okay, that means you can divide the value. Here 3 is common, that means we can divide the whole product by 3. That means we are going to get the value as 1, then x2 by 0 and x3 by 0. Therefore, we can write x1 as, we can make the elements 1, 0, 0. Okay, 1, 0, 0 because that is the thing we already chosen here, right? Capital X as x1, x2, x3. Okay, so now we got one eigenvector. Go for the next case. So the next case is what? When lambda equal to, yes, the value is 2. The same thing, now we put the lambda value as 2. Okay, so 1 minus 2 is minus 1, then 0, 0. The next thing is 0, 1, minus 1, 0, minus 1, 3 minus 2 is 1. Okay. Then into x1, x2, x3 equal to 0, 0, 0. Okay, now we go for first and second. Okay, if it is same or different. It is different one. Okay, that means we can choose first and second. We are going to start here. So 0, 1, 0, minus 1, minus 1, 0, again 0, 1. Okay, this way I want to choose the elements. So we can put the values of x1, x2, x3. Therefore, x1 is what? Sorry. X1 is take the cross multiplication. So which is 0 minus 0 and x2 by again 0 minus 1 into minus 1 is plus 1. Then x3 by, yes, the value is what? Minus 1 minus 0. So from this we can write x1 by 0, x2 by minus 1, x3 by, yes, minus 1. So here the sign is common, that means we can divide that side. So finally we are going to get x2 as 0, 1, 1. Okay, the next thing is we are going to see lambda equal to 3 in the next class. Okay, thank you.